Welcome, my name is Brian Nelson. This is the 6th lesson in the Introduction to Programming with C# course. In this lesson, we're going to introduce classes. Let's get started. C# is an object-oriented programming language. This means that the programmer can define objects that contain code and data. As we mentioned in our overview of C#, objects can represent real-world entities. This allows the programmer to organize code and functionality in a way that is easy to visualize. There are many object-oriented capabilities, but for now we're only going to focus on the most basic of them. We will get into more capabilities of object-oriented programming in future lessons. When a class is instantiated, it becomes an object. This object can be assigned to a variable for the programmer to use. A class variable is a reference type. This means that the variable contains a pointer to the memory that stores the object. C# manages most of the complexity of pointers for us. When we use the object variable, C# uses this pointer to find the memory location for the data in the object. A class is the definition of an object. A class definition can have several different types of functionality defined. These include a constructor, functions, methods, and properties. Before we discuss these 4 different types of functionality that can be defined on a class, we need to understand parameters. Parameters are variables that are defined as part of the signature of these different pieces of functionality. This allows the programmer to specify what data must be passed into a method to execute the given piece of functionality. The parameters can be any of the different data types we have already discussed, or they can be other classes that the programmer has defined. You aren't required to use parameters. They are an option that is available to you. And we will come back to parameters when we start setting up classes in Visual Studio. Now we're going to discuss the constructor. The constructor is a block of code that allows the programmer to set the state of an object when it is instantiated. It is executed immediately to ensure that the object is ready to use. It's not always required for the programmer to define a constructor for an object in C#. They are available if required. Let's take a look at defining a class and creating a constructor in Visual Studio. Okay, I'm going to set up a new project. It's going to be console app again. Call it lesson 6. All right, in this lesson, we're going to create a class. To do that, you can right-click on the project, say Add, and we're going to add a class. And we're going to call this temperature reading. So this is for a temperature during the day. I'm going to start with that. So the first thing we're going to do is we're going to create a constructor. And what the constructor is where we set up things. So we're going to set up a constructor. And you can have multiple constructors if they have different parameters. We'll get into more. That's more into advanced classes, and that'll be in the next course. The definition of public here in lesson 8, we'll get into a little more on what those can do and how that works. So basically, we define public class and then the name of the class, and then the constructor it's just a method of code that has no return type. The constructor's name matches the name of the class. So that itself is how you define a class. And we've defined a constructor. There's nothing really to do yet. Now that we have a class created and the constructor is defined, we can start adding functions and procedures. A function is a method that executes code and returns a value. A procedure is a method that executes code and impacts the state of an object, but that does not return a value. In C#, the terms functions, procedures, and methods are often used interchangeably. This course will focus on using the term method to define a block of code in a class. It might return a value or it might not. It may take in one or more parameters or it may not. Let's take a look at setting up these different methods now in Visual Studio. We've got the constructor set up, so now let's create some functions. And so what we're going to do is create a function to convert from Fahrenheit to Celsius. What we're going to do is public, it's going to return a double to Celsius and double temperature Fahrenheit, double temperature Celsius equals, so we have Fahrenheit, so we're going to go 5 divided by 9 times the temperature Fahrenheit minus 32. And then we need to return temperature Celsius. So what this is a function. The name of the function is to Celsius. It returns a double. And then the parameters that are passed in, or the parameter, is the temperature in Fahrenheit. In a function, you must return a value. And so you do that with the return statement. What we do here, the first line of the function calculates the Celsius temperature. It returns that value from the function. And now let's do public double. We'll also do to Fahrenheit. And that's going to get passed in double temperature Celsius. Currently it's red because we don't have a return value. Double temperature if I could spell it, equals 9/5. I'm going to do 9 divided by 5 times temperature Celsius. And we're going to say plus 32. And then we have to return that from the function, temperature Fahrenheit. Now we have two functions, and we can go from Fahrenheit to Celsius and from Celsius to Fahrenheit. Great, so that's useful. Let's say we want to create a double temperature. What we've got here is a module level variable. We'll come back to this a little more in lesson 8. But now we have a basic constructor, and let's say we create another constructor, and now we're going to say double temperature. We're going to say temperature Celsius. What we can do in the constructor is we can set up this object. So we have a default constructor here that does nothing. And then we have a constructor that will set the temperature in Celsius. Now, one other thing we're going to do here is we're going to say private int, and we're going to call it hour of day. You notice that I've got underscores here. I use those to say that this is a module level variable. And again, we'll come back to this in lesson 8 when we talk a little more about that. And so what we can do is we can also pass in another parameter called int hour of day. I can now set that equal hour of day. Now, what we might want to do is also allow you to change that. So the constructor can only be called when the class is instantiated. We might say public void set temperature from Fahrenheit. We can say double temp. Okay. What this is now is a method that does not return something. The way you specify that this block of code doesn't return anything is that it's void. Okay, and void just means nothing is going to come back. So what we can do is now we can say temperature equals to Celsius. We're going to call the function that we've defined And the functions themselves didn't change this object, okay? They didn't change the temperature reading object. They just perform a conversion from Fahrenheit to Celsius. They don't impact the state of this object. The set temperature impacts the state and it uses the conversion to allow us to go from Fahrenheit to Celsius and then set that value. Properties are the final aspect we're going to investigate for now when defining code blocks in classes. A property is really a shorthand coding practice for pairing of a function and a procedure to set and retrieve a value that is stored in an object. Let's go set up some properties now in Visual Studio. Now let's talk about properties. What we have here are two variables. Now, what we could do, and what a programming language like Java might do, is say, all right, public double get temperature, and they would return the temperature, and then public void set temperature, double Celsius. Okay, so in Java, you would do something like this, where you have a getter that returns the value and a setter that sets private values. So in C#, we have properties. Public double temperature. This one line of code is equivalent to all this, okay? So we're gonna get rid of that other code. And we can also do int hour of day, get set. And we're gonna get rid of these two internal variables. We are going to use those properties now instead. So we're gonna set hour of day. Now there's an alternative. If we wanted to leave, I'm going to undo now. If we want to leave these as a variable, what we can do is let's change our syntax a little and return temperature. So here we're going to say temperature equals value. All right. Now let me reformat this a little. These two properties here, one is a condensed format and it includes the definition of a private variable automatically. Alternatively, you can define your own private variable and return the value in the get, and you can set the value in the set. And you use the keyword value to be whatever gets passed in. In this case, the reason you would use this format over this format is if you want a backing variable, or you want to run some additional code, because we could run any additional code that we wanted here. I'm going to get rid of this hour of the day, and we'll leave one of these with a backing variable. You can see here, I am not using the getters and setters. I'm setting the variable directly here. Here, I'm using the property definition. Now that we've defined a class, we can define a variable to represent an instance of it. Once instantiated, the class instance can be programmatically interacted with. To instantiate a class, we use the new keyword and assign it to a variable. Let's take a look at instantiating a class in Visual Studio. So now we're going to use this class, and I think this will start making things a little more obvious. We're going to go to the program. Now we can define, we're going to actually create an instance of the temperature reading. So temperature reading, so we're defining the type, and we'll call it temp1, so we can equals new temperature reading. The new keyword is used to define we're creating a new instance of this class, and we can do it like that. We can also, I'm going to do it again, and we'll call this temp2 equals new temperature reading. And now there are multiple constructors. So we're going to say 2, and we're going to set the temperature in Celsius to, 30 degrees Celsius. What we can do here, though, this one doesn't have an hour, so we're going to say temp1.hour-of-day equals 1, and temp1.set-temperature, we're going to set this to 90 degrees. So this is, and I'm going to make a note, temp in F, and here, temp in C, okay? Okay, so we're going to run this and see how we've done so far and see if we've got any problems. So we've got a new temperature, and so if we look at the properties of this, hour of day 0, temperature 0. So that's the default state because this constructor didn't do anything. Now we're going to set the hour of day to 1. Now we're going to set the temperature. So we're going to step into that. So I'm going to hit F11. Now we're calling set temperature. So we're going to set the temperature. And we are going to step into this method. So we're passing in 90 degrees Fahrenheit. I'm going to step in there. So now we're running this code up here. All right. So 90 minus 32 times 5/9. It's doing integer math instead of double math. So let's fix that. All right, and let's rerun this now. So you got to be careful when you're using constants like that. You're going to hit F5, and we're going to see how this works. So we're going to hit F10, and we're going to step into this with F11. So we go into that code. We're going to go into, so I hit F11 again, F10. Okay, so now we have a value in Celsius of 32. We return that, and now we're setting, if we say I'm going to step into this again. Well, it didn't let me step into it. Okay. But anyway, we'll look at the properties of this. You can see the temperature property is 32.2. The temperature variable that's defined in there is 32.2 as well. Now you notice there is no variable defined for hour of day because of the way we define the property. I'll come back here. Because the hour of day is set up in this condensed format, there is no backing variable. So you don't see that in the debugger. Let's go ahead and run this again. And this time I'm going to just put my breakpoint at the end. And I'm going to just hit F5. Now what we can do is, and we can look down here, our hour of day is set to 1 and 2, and our temperature is 32 and 30. This is how you can use that class. So now we have a class that stores both the hour of the day and the temperature. And we can create multiple instances of that and keep track of the different hours of the day. So let's define a third temperature. And 3, and we'll call it 28. Something like that. And just so we temp in C. So we can create a list of that. But what we can also do is we can create a temperature reading. And we can define this as an array, and we'll call it an array called temps equal new temperature reading. But now we're going to say there's 24 readings in a day. Okay. And so now instead of storing this like this, we can use our array terminology, temps, and we'll say 0, and so equals new temperature reading, and we can say, so hour 0 is, and we can say like 16 now, fine. And then, so what we can do is we can copy that. And so we can now say 1, 2, and 7. Say the temperature is going up, and we'll change the element of the array. This is just much more condensed and easier to use. Or we could do something like, let's comment this out. There we go. What we can do here is for int I equals 0, I less than 24, I plus plus. Now we can say temps I equals new temperature reading, and we're going to just use I in that from that loop. We're just going to set the temperature to 0 for now because we don't have a reading. And let's run this. So now you can see each time we go through the loop, I gets incremented by 1. So now we're setting I as 1. So 0, 1, 2. We can look, if we look at our array of temps, we can see as we go through, a new reading here gets created. So we're filling up an array of temperature reading objects. That wraps up our 6th lesson. In our next lesson, we will take a look at the static modifier and how it can be used in classes.